So, welcome to a new webinar on intelligence, strategy, and security. In this case, focused on aerospace intelligence. So, we'll be looking at intelligence technologies, strategy and security, AI, machine learning, the new large language models, and we'll be focusing specifically on aerospace, but the webinar will be addressing also more generally intelligence technologies, new frontiers of intelligence technologies, and what can be done with new AI systems, in particular with generative AI, both with generative AI and machine learning. We'll be looking at several examples, including aerospace strategy, as well as the decomposition of sunspot chaos and self-organized criticality with topological machine learning. So this will be another of the applications we'll be looking at. My name is Carlos Pedro Gonçalves. I'm an associate professor at Lusophone University in the School of Economic Sciences and Organizations in the Department of Management on Civil Aviation and Airports. I'm also a researcher on complexity sciences, chaos theory, risk science, quantum technologies, artificial intelligence, strategic studies, studies in intelligence and security. I have also research in fintech and financial risk. I'm also a software developer in the fields of complexity sciences, chaos theory, artificial intelligence, data science, quantum technologies, as well as intelligence technologies. It's in the crossroads between intelligence technologies, complexity sciences, and artificial intelligence that this webinar takes place. So the webinar is, in terms of specific disciplinary context of the webinar, we'll be looking at intelligence and security in general, intelligence technologies also in general, and also we'll be dealing with chaos theory and complexity sciences. Specific application context, we'll be looking at aerospace security, as well as solar science in the case of sunspot data and the relationship and why we need to look at sunspot data in regards to aerospace security. That's the last part of the webinar. But we'll be looking, besides that, we'll be looking at aerospace strategy in general, space agencies, and so on. So the webinar is divided in three parts. The first is the concept of intelligence and intelligence technologies. The second part is, and it will be dealing with intelligence and intelligence technologies in general. The second part of the webinar regards generative AI and intelligence technologies, namely using DeepSeek for strategy building. In this case, we'll be looking at the specific example of the European Space Agency and applying both DeepSeek and Grok as well. The third part of the webinar is dedicated to solar activity and aerospace security, understanding and predicting sunspot dynamics and why this is relevant, as well as the decomposition of sunspot dynamics using smart topological data analysis, combining topological machine learning, adaptive AI systems, chaos theory, fractal analysis, and other methods from nonlinear time series analysis. So this is the last part of the webinar where we'll be showing the application of machine learning and adaptive AI. So this is the first part of the webinar, and we'll be looking then at some concepts that are relevant in terms of the whole context of the webinar. So the webinar is not only of interest to those dealing specifically with aerospace security, it addresses intelligence as well and intelligence technologies in general, with aerospace security being a specific and aerospace strategy being a specific area of application. So first, let's look at intelligence. So intelligence is rooted in intelligentsia, Latin, and it's a term composed of intus, which means within, and legere, which means to choose, to elect. And so intelligence is a dispositional systemic capability to perceive, to capture, to select, and to process data and knowledge from cognitive co-dynamics linked to dynamics of interpretation and comprehension, genetically incorporated in all the systems. So this definition of intelligence which comes from a philosophical and cognitive science standpoint and works from the root of the concept, is can be integrated and worked in the context and applied to the context of intelligence and security, or in the so-called intelligence within the strategic studies and intelligence and security context. And when we look at this context, which is the strategic studies context, the security context, and so on, we see two types of intelligence, two general types of intelligence. One is strategic intelligence, which refers to all activities that involve the perception, the capturing, selection, and processing of data and knowledge, from cognitive code dynamics linked to dynamics of interpretation and comprehension. So this is the general definition of intelligence, but now, in the case of strategic intelligence, towards a specific goal, which is the production of knowledge necessary to strategic decision. And at the tactical level, we see all activities that involve the perception, capturing, selection, and processing of data and knowledge, from cognitive co-dynamics linked to dynamics of interpretation and comprehension towards the production of knowledge necessary to tactical decision. So we are dealing here with two types of intelligence in the context of strategic studies, strategic and intelligence studies, which one is linked to strategic decision, the other to tactical decision. We can also speak of operational intelligence linked to the operations themselves as they are taking place on the ground. So, but basically, looking at strategic intelligence and tactical intelligence, it's important to look at the concepts of what is strategy. So, at the concept of strategy and tactics. So, what is strategy? What is tactic? Strategy is rooted in the Greek, and it refers to the art of the general. Comes from strategos, general, and which in turn has origin in stratos, with the meaning as of that which is placed in order. So we have here a placing in order towards a final goal. So this refers to military force, the stratos, meaning of that which is placed in order, military force, and agos, with the sense of leader. So we have here, in the etymological origin of the term strategy, a matricial notion that links it to, as a matricial notion, worked from the etymological root, commits the term strategy to a sense of leadership. So, as the art of the general is one way to define it. But we can look at strategy in greater detail, both in regards to the Western and to the European matrix, but we can also look at it from the Asian matrix, and looking at both, at the way in which both the strategic studies traditions, European tradition, and the Asian traditions look at strategy, we can synthesize a concept of strategy as an activity that can be defined as the adaptive application of knowledge in the planning and organization of actions, and this is linked to the Greek root, aimed at, and we have here intentionality, objectives defined as a function of previously established ends. In this sense, the intelligibility of a strategic decision rests upon a relation between the ultimate ends and the corresponding strategic objectives, and the different ways in which these objectives and ultimate ends can be achieved. That is the chosen path. A path that which leads to attaining the strategic objectives towards the final fulfillment of the ultimate ends. So the chosen path, the output of the strategic decision, sometimes is also called a strategy. So in this process, in the process of strategic development, where one thinks about how one can achieve one's objectives, one's strategic objectives. The output of that process is a strategy, a path. And that path is sometimes also called strategy, but basically it's the strategic plan. So this, sometimes in the literature, especially in the management literature, one looks at strategy. Sometimes the term strategy is applied to this output of this cognitive process, but strategy in itself is an active. The strategy development can be looked at as this activity that leads to a specific path towards attaining one's objectives that are defined in relation to one's ultimate ends. Tactic is different. So tactic is different from strategy, and it's rooted in the modern Latin tactica, which in turn is rooted in the Greek tactike techne as the art of ordering. So tactikos, fit for ordering, and tasso, to order, to arrange. So tactic is the art of putting in order in a way that fits the fulfillment of the strategy. So for a given strategy, we can have different tactics, and the tactic is more fluid. The tactical level involves then a combinatory of means, motion, and acting at the times of opportunity towards us. And here we have the concept of kairos, the Greek philosophy concept of kairos, and we could review Aristotle for that. If you are anyone is interested in that, one can review Aristotle. But one can also review Sun Tzu's Art of War, and one finds there a similar concept, so similar conceptual thinking regarding the way one acts. So the tactical level involves a combinatory of means, motion, and acting at the times of opportunity towards a successful implementation of the strategy. So the tactical objectives are in this way more fluidly set towards the fulfillment of the strategic objectives. So the tactical level is more fluid, and it's linked to this combinatory of means. So intelligence, intelligence is this activity. All the activities. When we speak of strategic intelligence, we are dealing with a set of activities. So intelligence is linked to so intelligence in itself is a dispositional systemic capability. But when we speak of intelligence in the context of strategic studies, we are referring to specific activities that involve the exercise of this capability to perceive, to capture, to select and process data and knowledge from cognitive co-dynamics, okay, linked to interpretation, comprehension, towards a specific goal. One is to support the strategic decision, strategic intelligence, and the other to support the tactical decision, which is tactical intelligence. So this is intelligence. But in the case of intelligence, in the intelligence and security context, sometimes intelligence is referred to as there is the intelligence product or the intelligence as product. And this often appears in different ways in which the intelligence community refers to the output of the intelligence activities. So intelligence is often also used in this community to refer to the product of or output of intelligence activities, that is, the knowledge necessary for decision making, be that decision a strategic decision, strategic intelligence, or tactical decision, tactical intelligence, or even an operational decision, and we're dealing here with operational intelligence. So when we look at intelligence as product, we need to look at intelligence market, not necessarily a market in the sense of in the economic sense, but we also have that market, intelligence market in the economic sense when we're dealing with business intelligence, for instance. But there are major consumer segment, intelligence consumer segments. And we have here defense and security, and we have different operators operating in the market for intelligence, also in the defense and security context. But you have in terms of consuming intelligence products, looking at intelligence as intelligence products, we have defense and security, policy making, the political sector, the corporate sector, business intelligence, and others. For instance, terrorist organizations planning a terrorist attack are will produce intelligence activities. So we have also these the intelligence activities are implemented by both state actors and non-state actors. And in the case of non-state actors, you can have legitimate, completely legal contexts like the corporate sector in business intelligence, but also those implementing illegal activities, including criminal organizations and so on. Even for cyber attacks, we have hackers that will develop intelligence activities to find out vulnerabilities in systems and how to exploit those vulnerabilities. So this is even zero-day threats identifications in cybersecurity. And you can check online what the zero-day threat is, but even that is incorporated in intelligence markets. So, but basically, looking at intelligence, one thing that is particularly relevant is the intelligence cycle. And the intelligence cycle is not only relevant to look at from an intelligence for someone working on intelligence, but also to look at intelligence operations in general and how they may be transformed by technology. So, looking at some foresight into the intelligence work and the future of intelligence work, we need to consider in this intelligence cycle how technology may impact this cycle to produce that foresight into how intelligence work may change. And intelligence work is being exponentially uh, changed by the accelerating technologies, in particular the digitalization linked to globalization, to the Internet of Things, and so on, the fourth industrial revolution. Um, but also a set of technology which leads to data abundance, to big data, and not only big data, but sometimes personalized data, availability of online data, and new sets of data and data types that are being produced: video, speech, written text, but also spoken. Okay, the quantitative data, qualitative data, so on. We have a whole set, a diverse set of data. So we can we here we deal with phenomenon like big data, small data, and so on, in the data retrieval pipeline, which supports also open source intelligence and cyber and intelligence involving cybernetic systems, including looking at Internet of Things, looking at social media, and so on. SOC social media intelligence, is another is one part of this. So, and in the case of the business sector, we have the same thing. So, when we look at a problem and looking at intelligence cycle, we have first the planning and direction. So, this is mainly a human effort. We are dealing with governance, with the decision maker, and the decision maker has a problem that needs an answer. The decision maker has intelligence needs, and those intelligence needs lead to specific intelligence concerns, and we need to look at the problem, and when looking at the problem, one needs to identify what uh, what do we know about that problem and what we need to know about that problem but do not know, and what we need to know about that problem but do not know, we need to find out. And this is where intelligence activity starts. So we have to plan. In the planning and direction level, we have both the definition, the understanding of the problem, that first work on the intelligence problem, which involves looking at the decisional problem that we have. But we also have then the development of a plan for data retrieval, for data collection, and knowledge production necessary. So the types of analysis that we'll need to perform in order to get that knowledge that we need for decision making, be it strategic decision making, tactical decision making, operational decision making, and so on. The type of problem will dictate the level of both. The type of problem will dictate the type of data that we'll need, the analysis, and all these contexts can be, depending on the problem, can be subject to more or less automation. In the case of a continuous data stream that we can retrieve, we can introduce a permanent intelligence cycle working. If we have if we have that continuous need for knowledge to support decision making. And we have here data retrieval pipelines linked to data retrieval, to data processing, which is where data science enters into play. And then a whole set of analysis that involves analytics for decision making, and that companies often implement. So the corporate sector often in the data science side has this often has been introducing this pipeline. And in the intelligence and security and defense, we also have that. But there's also the episodic need for intelligence. That is, we have a problem, a new problem, and we have to look at it, and we need information. And then we have this whole other set, and we have a new intelligence cycle linked to that new problem. So, planning and direction, we have to plan both the types of activities that we'll have to implement, the intelligence sources that we'll need, the how we will collect the data, and that and this data collection stage is already occurring in according to an intelligence data retrieval and intelligence production cycle and plan. So after we collect the data, the raw data, it often needs processing. And this processing of data can include exploratory analysis, the collection of different data sources and comparison, and the gathering all everything in the same intelligence effort. So we need different sources we can that may have different data types. We may have different databases. We may have different intelligence sources, and depending on the problem, you can have human intelligence sources, HUMINT, but you can also have digital sources and so on, and you have this diversity, and we need to process everything. Sometimes that processing occurs within a single database, but often it occurs with different databases that need to be operated upon, and different intelligence sources. And some, for instance, if we talk to a person that is in the country X, Y, or Z, and that person gives us specific relevant information, then that will have to be processed as well. in terms of, but looking at what that person said, interpreting what that person said, comparing with what other data that we have, and so on. So here we have different types, different sources of intelligence, different types of intelligence activities involved. Not to be confused with espionage, human intelligence. For instance, companies implement human also takes place at the level of companies. For instance, in the corporate sector, whenever you ask your clients, whenever you speak to your clients asking about the service and how the service is going, that is human intelligence, for instance. So it's intelligence retrieved from human sources, and that's not espionage. Espionage is one way of getting is one type of human where you get information from human sources, in this case, spies. So not to confuse, one cannot confuse intelligence with espionage. Espionage is one way of getting information. So, but there are others. In the corporate sector, for instance, that's illegal. So we have here processing, then processing that data, and data science has been one major source of has operated and operates in these two areas of collection and processing, or exploratory data analysis, data cleanup, so the data wrangling process. Those so that processing, there's a pre-processing of data and a whole processing of data of raw data, trying to find errors, trying to find initial patterns, and to place that data in a way that one can apply different data analysis methods. And that's where it enters the all source analysis and production. We need to look at all intelligence sources that we worked on, um, and we need to produce a synthesis. We need to compare, look at the patterns, see where, if there is any ambiguity, see where one source confirms another, and so on. So there's this depends on the specific problem at hand. This is where machine learning, this analysis and production is where machine learning has been greatly impactful and is going to be strongly impactful. All source analysis and production. Finally, we have the intelligence report and the dissemination or the intelligence or the synthesis in terms of cognitive synthesis, and we have the knowledge that we need for decision making, possible recommendations of course of action, and we have here the dissemination towards the governance and towards solving our problem. So this is the intelligence cycle, and different sources you can click on that link. This is actually adapted from the CIA source, so you can click on the link and there's an explanation of each stage of the intelligence cycle from the point of view of the CIA. I gave you here the point of view of both intelligence and security, and also corporate sector, business intelligence, and so on. So, um, looking at all source analysis and production, this is an interesting point because it's becoming a hybrid effort. So you have the and if we look at collection as well and processing, often here we are starting to see strong automation in collection and processing. For instance, in the business sector, we are seeing this occurring, and also in the defense and security sector. But all source analysis and production is an interesting point because you need humans here, but the humans are being supported by AI. But until recently, you could apply machine learning to for data mining, for working on different data sources, and you had the human analyst, a human intelligence analyst, looking at the results and comparing everything and considering things and reaching specific conclusions, recommendations, and so on, trying to gain strategic foresight, and all this. So this is the all source analysis and production. But now we have large language models. And large language models are somehow changing this to a point. We'll be seeing that in practice. So it is now all source analysis and production, which until recently was mainly the domain of humans, is now a hybrid effort. We have the human element, and the human element is essential, but AI is being used as a tool, and AI with which we can talk to. And this I'm referring specifically here to large language models, to these ChatGPT and so on, and we'll be showing that. So examples of where AI is used: machine learning for data analysis, data mining, and so on. So knowledge extraction from data, basically, and large language models that can be used to suggest strategies and courses of action, as well as work on data and produce specific models, including models of strategic interaction. We'll be seeing that in the second part of the webinar. So, in the intelligence cycle, when we look at the intelligence cycle, we look at how to retrieve the data that we need. And here we have an increasingly technological um, the technological dimension of data retrieval has been strongly transformed, is being strongly transformed by exponentially accelerating intelligence technologies, the retrieval of the data, the retrieval of the intelligence, the retrieval of information and knowledge. So all that is being transformed by intelligence technologies. The second part is how to work that data so that one can extract knowledge from that data. And when we look at knowledge, we need to consider uh, here something about knowledge. We need to look a little bit better at this issue that is knowledge, at the concept of knowledge. And from a cognitive standpoint, any production of knowledge is supported by an organizing activity that acts intentionally according to rules and whose objective is the solving of problems and its own replication. So when we talk about knowledge, what knowledge in which knowledge? The knowledge here is the key point when we look at the intelligence cycle. And we can have knowledge produced by a human agent and knowledge produced by an artificially intelligent system. But the knowledge produced by the artificial intelligence system, where the artificial intelligence system is being used as a tool, is needs to be the human agent still needs to look at it, at that cognitive synthesis, and to produce his own or her own cognitive synthesis from that knowledge production. So any production of knowledge is supported by an organizing activity that acts intentionally according to rules and whose objective is the solving of problems and its own replication. So when we look at this, we have here the solving of problems, intelligence problems in this case, towards decision making, strategic, tactical, operational, so on. Okay, so but here the type of the cognitive process through which knowledge is produced in the case of AI systems is algorithmic. It's different for humans. So the access to knowledge, as well as any attempt of definition, can only be made through this activity of the organizations of the agents, beings, entities, subjects, both human and, in this case, the artificial intelligent tools that we produce as support tools in our knowledge production. And any production of knowledge is supported by this organizing activity that acts in accordance to rules that have as their objective the solving of problems that promote, in the case of a biological organism, the organism's survival and adaptive fitness, but this definition also applies uh, 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 to the human organizations, to strategic intelligence, to tactical intelligence, and so on, in the different contexts where we speak of where these activities are employed towards decision making. Okay, both in the um, economic sector, in the business sector, in the political sector, in the defense and security sector, and so on. So the value attributed to cognition imposes that one should know something about the term cognition itself. And this is particularly important when we look at the new cognitive tools, because these new cognitive tools that support intelligence activity are artificially intelligence tools produced in a way that you can communicate with them in natural speech, and they respond in a way that can produce synthesis from complex data sources, from different data sources, and it can even analyze a geopolitical context and produce intelligence synthesis, including strategic suggestions. We'll be seeing that in the second webinar. So let's look at cognition, because we need to consider the artificial cognition, which is different from the human biological cognition, but and is mainly an algorithmic process. We can speak in the case of human of self-awareness, the importance of intuition, and so on. But in the case of an artificially intelligent system, it is uh, it is directed by a base algorithm, by a base knowledge, its knowledge base, by the training data that was used, and so on, and the type of technological infrastructure in terms of algorithmic infrastructure, and the way it is programmed to learn. So the learning algorithm itself. Uh, uh, this is different from a human. So, but the value attributed to cognition now with cognition in the case of intelligence is hybrid. We have the human on one side interacting with the artificial intelligence system on the other. So, the value attributed to cognition imposes that one should know something about the term cognition. The Latin root of this term or the Latin root is in cognoscere, and the Greek root is let me see, gignosko and gnosis, and in Sanskrit is jnana. Gig, let me just confirm, gignosko, yes, gignosko and gnosis. And in Sanskrit is jnana, with the co-meaning of conjoint capture and comprehension. The Indo-European common trunk allows the relation between the term gnosis and the term genesis, which allows in turn the signaling and codification in the definition of the term cognition of a constitutive genetic sense that attributes to it a replicative value. In this way, each cognitive act envisions its own replication. So knowledge here appears here in relation to cognition, is linked to the coexistence with that which is or can be known. To know and to be known are folded in the same cognitive act. We can talk about knowledge from its production slash creation. That production of knowledge now is a hybrid effort. And but in the case of intelligence, it has always been supported by technologies. So when we speak of intelligence technologies, it's not something new. For instance, you have here the ninja tools. So the ninja or shinobi is the Japanese term for intelligence operatives that were also employed as that were specialists in hybrid warfare and in intelligence warfare, in intelligence activities. Though, so and they had spy tools, they had intelligence technologies. You see here. Um, taken from Wikimedia Commons, a picture of intelligence technologies used by the ninja in to support their activities. So This is another example from the Bansen Shukai of tools used by the ninja. So the ninja used tools in their activities. You have even devices to amplify sound in order to listen better. You had breaking and entering devices, devices to fire devices, devices that were employed in unorthodox warfare methods, but also in espionage. You had different technologies that supported their activities. So the spy gadgets, basically, were employed by already by the ninja in the past. So this is just to illustrate that intelligence technologies are nothing new. However, what is new is that we now have a data-rich environment, a digitalization of the space of human relationships, and we have in this data-rich environment multiple data sources, multiple data types, free availability of this data in the digital space, in cyberspace, free, and we have also freely available tools to work this data, uh, other paid, also paid tools to work this data, but expansion of AI and machine learning, and also computing power. This added with no, with strong computational knowledge, of programming languages and so on, and you can and we have here this data-rich environment and the tools to process that to process this data, and this is what's changing strongly intelligence in terms of what the impact of the fourth industrial revolution, which is the cyber physical systems revolution. Cyber physical systems, and one could add cognitive, so CPC, cyber physical cognitive systems, which includes the Internet of Things and the AI incorporated in the Internet of Things itself, so the AI of Things as well. And we have all these available to ordinary citizens, to companies, to the state intelligence and security sector, and so on. So we have this data-rich environment, and this is changing intelligence. So this is, and this we'll be looking at this in greater detail in the second part of this webinar, which is looking into aerospace strategy using DeepSeek, but we'll also look at it we'll also see Grok being employed. But we'll apply first DeepSeek, which is impacting strongly the AI community, the DeepSeek. I'm talking in the week where DeepSeek was made a great splash in the technology sector, and it has been subject to continuous cyber attacks as well, and it led to a fall of stock market prices in the U.S. In several U.S. tech companies, including Nvidia. But we'll be looking at, so it's a new technology, comes from the Chinese, it comes from China, and we'll be looking also at Grok. Grok is the X network, social media AI system that has also been recently launched. And we'll be seeing at those two technologies being used and illustrating this transformation in intelligence technologies. But that is for the second part of the webinar. So this ends our first part, and see you in the next section of the webinar. In each this will be placed on a playlist on YouTube. And for each webinar, the link to the playlist is given in the video description, so you can see in the video description the link to the playlist, to the full playlist, and this is the first. So we'll end it now, and so see you in the second webinar.